Hello students, my name is Nariman Merim. I'm located in Baku and here you can see my mobile and email. Today we will discuss Edexcel paper 1PR. Letter R indicates that this additional time zone. Let's start. So this is the paper. Here are equations that will be given at the exam. First question. Answer all questions. Identify the circuit diagram symbols. So symbols you should learn. So this is cell, this is lamp, this is fixed resistor. This is light dependent resistor. Next question. Question 2. Diagram 1 shows the orbit of Mercury and the orbit of Earth. So Mercury is a bit further. And what else? Describes two differences between the orbit of Mercury and the orbit of Earth. Use diagram 1 to help you with your answer. So what we see that Earth is further away, so we have different radiuses, and Earth will be moving slower, so different speeds. So no more questions. Another question. B. Diagram 2 shows the orbit of a comet and the orbit of the Earth. So what we see is that comet's orbit is more squashed, more elliptical, and it is in another plane. So we have these two answers: different planes, and comet elliptical orbit, Earth circular orbit. No more other questions. The diagram shows an electric kettle, coil of wire inside. The Sankey diagram, so let's look. Sankey diagram shows the energy transfers that take place in 1 second when the kettle hits some water. What is the energy input of the energy input? So what we can say that this is energy input and it equals this output plus this output. So we should add these two values, and I should make the marker a bit smaller. Let's say it like this. What is the energy output? So we add these two values. So input will be used and lost, added, give us 2500. This is answer D. Do we have more questions? No more questions. So this was question 3. B. There is a large insulated coil of wire inside the kettle. Explain why this coil of wire gets hot when the kettle is switched on. 2 points we should get here. Current flows, coil have resistance, and electrical energy is transferred into thermal energy. So out of these 3 points, for sure we'll get these 2. The power of the kettle is 2.5 kilowatt when operating at voltage of 2030 volts. State the equation linking power, current, and voltage. So here they ask equations that you should learn by heart. So this equation will not be given. So here we have power equals current times voltage. Shows that the current in the kettle is about 11 amperes. So power in kilowatts, so we change into watt. And now we should find current. So we have power equals current times voltage. Upon this, we can draw this pith triangle. If we cover, so we need current, so we cover current, what we see? We see power divided by voltage. So, to find current, we should divide power by voltage. So we divide power by voltage, and we get 1086. Here we will keep 3 significant figures. So if you don't know how many, keep 3. So here we keep 3 significant figures. Finished. The plug of the kettle is fitted with 30 amperes fuse. Describe how the fuse prevents the coil of wire from overheating. In case current exceeds 13 amperes, fuse, which is low melting point wire, melts, and breaks the circuit. Finished. This question finished. Question 4. A student makes some statements about how light from an object forms an image in a plane mirror. Only 2 of these statements are correct. Tick the 2 boxes in the table to show the correct statements. So first, I ticked already. Let's see. So angle of incident equals angle of reflection. Image in plane mirror is virtual. Just remember. Question B. The diagram shows a ray of light traveling from air to glass. Measure the angle of incidence, angle of refraction for the ray. So here I already marked angle of incidence between ray and normal, and angle of refraction between ray and normal. You use protractor and you find that angle is about 45 degrees plus minus 1 degree, which is accuracy, precision of protractor. Angle of refraction is about 26. State the equation linking the refractive index, angle of incidence, angle of refraction. So it is n equals sine I over sine r. Finished with this page. Describe an experiment to determine refractive index of glass block. In your answer, you should refer to the apparatus that you should be used, the measurements that should be taken, the method of analysis, the data. You may add a diagram to help your answer. So here I have a diagram. So we actually need ray box, nothing else. So we put glass block on paper, outline, so draw line around with pencil. Then we put 2 crosses at position 1, 2, 3, and 4, and draw line 5 and 6. Then we have these points to draw line 7. So we have actually angle of incidence and angle of refraction. The problem was to draw angle of refraction. Now we have it. So now from this point we draw normal, which is line perpendicular to the surface. So we take glass block out. We have now one line, surface, incident ray, refracted ray, and we can draw normal. Then we measure angle of incident, angle of refraction. And to be accurate, we draw graph. Here are steps. So put glass block on paper, outline the block with pencil, send ray from ray box, mark points 1, 2, 3, and 4, draw lines 5, 6, and 7. Draw normal at one of the horizontal surfaces of block. Measure angle of incident refraction. We should repeat this experiment for 6 sets of angles I. Find 6 corresponding sets of angle R. Draw angle of sine I, again sine R. and find gradient using this formula y2 minus y1 equals divided by x2 minus x1. N will be equal the gradient. Finished with this page. Next question. An adapter plugged into the main supply is used to change a charge mobile phone. The photograph shows the adapter that displays the voltage and current reading of the discharges. So we have cable and cable from mains, and we see current. So current is 0.42 amperes and voltage is 4.80 volt. State the equation linking voltage, current, and resistance. So voltage equals current times is missing here. Let's put time here. So times resistance. Again, so we have now, so let's draw. So we have, actually we know the resistance. Resistance is voltage over current. This triangle I call V triangle, VRI, it is resistance triangle. And if you want, for example, resistance, you cover resistance with your finger and you see V over I. So resistance equals V over I. We substitute values and we keep, here we keep two significant figures because 0.42 for sure have two significant figures, and the 4.8 has three significant figures, so we keep out of 3 and 2 minimum. Minimum is 2, so we keep two significant figures. Right, let's go further. So resistance is 11 and resistance is in ohm. This is the symbol for ohm, unit of resistance. So finished with this question. The battery of the mobile phone takes 45 minutes to charge. The charging current is so much. State the equation linking charge, current, and time. Charge equals current times time. Calculate the time transferred to the charge transferred to the battery. So how I remember this formula? I remember this formula from current. Current equals charge per second. So I call it GIT triangle, Q-I-T. And this is current triangle. Everything should be in SI system, in SI units. So actually we already have this formula here, and what we do, we just substitute values into this formula, changing minutes into seconds by multiplying by 60, and we keep two significant figures. Why? Because 0.42 amperes is two significant figures. Next question. The cable connecting the mobile phone to adapter is charged for a much longer cable for the same time. Explain how this would affect the time taken for the battery to charge. Assume the same charge transferred to battery. Greater time is needed. This is our statement. Now explanation. Why? Longer cable, greater total resistance, smaller current. Same charge at smaller current requires greater time. Here we refer to our triangle. So if we need to know the time, we cover time and we see that it is charged by current. Time equals charge by current, smaller current, greater time. Finished with this paper. Next question. A Scientists investigate how the wavelength of sound waves in water varies with frequency. The table shows the data. So here we have frequency and wavelengths. So we should plot the graph. Here, the maximum value for frequency is 6. And maximum value for wavelength is about 1500. Let's see which graph we have. So if we count number of boxes, big boxes, 1, 2, 3, 4, 5, 6, and a bit. So I think that one box should be 1 Hertz. Now about wavelengths. We have 1, 2, 3, 4, 5, 6, 7. So if we make each big box 200, so we reach here by 1400, and this will be 1600. So our purpose is to occupy as much space as possible, and to be sure that examiner will not be able to make our scale 2 times bigger. So here, of course, we can make it 2 times bigger. Then we plot points 6, 250. So here, so from 5 till 6, so each division is tenths. For wavelengths, 200, 300, each division is 20, so half division is 10. So we plot points, and then we draw smooth curved line in between. This is difficult, but try several times, use a razor, and finally get. So best fit line should go between points, very close to them. Sometimes some points are above, sometimes are below, so above, below, and finally you have this smooth graph. So draw the curve of best fit. We did. Use your graph to find the frequency of sound that have wavelengths of 600. So 600. So 600 is here. 600 is here, and we come here to 2.7 Hertz. Plus labeling. So you see, let's look to the table. In the table we have frequency in Hertz. Copy this into your table exactly as it is. The same do for wavelengths. So wavelengths in meters. So copy this all downward. Let's see. So you see frequency in Hertz exactly repeated. Here wavelengths in meter exactly repeated. Here we have answer 2.7 Hertz. Finished with this paper. Next, describe the relation between frequency of sound and wavelength. So for all waves, we have wave speed equals frequency times wavelength. And again, we can use triangle. So speed equals frequency times wavelength. So if we need frequency, so we draw triangle. V is at the top, frequency times wavelength. So we cover frequency, and we see that frequency equals V over lambda. So frequency is inversely proportional to wavelengths. But even if we don't know this, from graph we can say that as wavelength increases, the frequency decreases, inverse proportion. We have inverse proportion. Suggest how scientists could improve her results. So let us look again to the graph. What we see? We see that first of all we can make greater range. of wavelengths, and we see that in between we have so values are not we have big gaps, so we can put more points here, intermediate points. So wider range, this is standard answer, and more intermediate values for this specific experiment. States the equation linking speed, frequency, and wavelength. So we repeat this equation. Calculate the speed of sound, wavelength 510 and frequency 3. So we substitute my values. Let us look. So here we have two significant figures, 2. Here maximum 3. So 3 and 2, minimum is 2 significant figures. This is why answer is given to 2 significant figures. When we round to 2 significant figures, so we keep 1. And when we talk about 5, we look, so this is less than 5, so this remains unchanged, and the rest becomes zeros. As a result, we have 1,500, this answer. So we should keep all values, 1, 2 values till 3. 5, so second value can be rounded up, down, or not changed, so 1500. So this is what we have. Finished with this paper, right? Now, question 7. The question is about pressure. Explain why it is easier to cut vegetable with sharp knife than with one that is not sharp. Pressure is force per unit area, so formula. Sharp knife means smaller area, means greater pressure. So we reserved 3 points. So you see 1, 2, 3 ideas for 3 points. Balloons are often filled with helium so that they float in the air. A small canister of pressurized helium is used to fill some balloons. Using ideas about particles, explain why the pressure in the canister decreases as the helium is used to fill the balloon. Less molecules are left, less collision per area, smaller force and pressure. So 3 ideas. This paper we answered. The canister supplies 18,000 cm3 of helium at pressure 2,300 kilopascals. The volume of each balloon is so much. The pressure exerted by the helium in each balloon is so much. Calculate how many balloons can be filled using the helium from the canister. Assume temperature of helium remains constant. So case 1 is when all gas is in a canister. So we have volume and pressure. Then we have, imagine that we have n balloons with such volume, as they say, and with such pressure. So this is case 2. Total volume of all balloons at this pressure. So then we have this equation P1V1 equals P2V2, which is given with substitute value, and we get 50. So we multiply left side, and then we divide by coefficient of n. Coefficient of n is 820,000. So product divided by one of the terms or coefficient. We get 50.82. The matter is that we talk about the whole number of balloons, so we don't talk about parts of balloons. This is why answer will be 50 balloons. Finished with this paper. Next question. The apparatus is used to investigate acceleration. So we have trolley, string, pulley. Here mass. So under gravitation this pulley moves, but of course there is friction. The trolley starts from rest and accelerate. Mass of trolley, acceleration. State the equation linking unbalanced force, mass and acceleration. So unbalanced. I forgot to put here unbalanced. So unbalanced. Let's put here unbalanced force equals mass time acceleration. Let's make it this way. Calculate the unbalanced force. So unbalanced force will be ma. So mass is given and acceleration is given. So we calculate. We see that each term is two significant figures. This is why we round up to two significant figures and give answer like this. What is the direction of the frictional forces acting on the trolley? So frictional forces in this case are against velocity to the left. State two places where friction occurs as the trolley moves, between trolley and bench, and string and pulley. Let's see. So it is a contact between trolley and bench and contact between string and pulley. Right. State the equation linking gravitational potential energy, mass, g and height. So this is the formula that you should memorize. Calculate change in potential energy of the 5 kilogram mass as it falls. So they show that it falls from the height 0.65. So we substitute values. We keep minimum, which is here to 5 kilograms. They don't show that it is measured more accurately. This is why we keep two significant figures. So 10, 2 significant, 65, and 5 kilograms for sure they can measure more accurately. So here we can judge ourselves that there is more than one. So 5.00, I think. So change is so much. State the kinetic energy gained by the trolley and mass if there were no frictional force. Change in kinetic energy equals change in potential energy according to conservation of energy if we ignore frictional forces, and it is the same 37 joule, the same as in previous question. Next question. There are many artificial satellites orbiting Earth. Table 1 lists some data for 3 different satellites. So 1, 2, 3 satellites, and this is data. Calculate the period of the Iridium satellite in minutes. Radius of Earth is given. So when we have radius of Earth and height, we need distance of the satellite from the center of the Earth. This is why first we calculate. So radius of Earth plus height. Height is here, 780. So we have formula speed equals 2 pi r over period. So we can draw triangle for this case like this. 2 pi r equals v times period. Again, 3 quantities. If we need period, we cover period and we see that it is 2 pi r over speed. So we use this formula, calculate values and keep maximum significant figures. Why? Because this is kilometers, and if you don't know how many, keep many. Right, keep many. Okay. Let us see if we skipped some questions here. Yeah, we skipped some questions. When we give answer, we divide by 60 to get in minutes, and we give answer in minutes. Calculate the number of revolutions per day for the Iridium satellites. So 1 day is so many minutes. So there is formula. Total. So no, each equals total divided by number. So if we draw a triangle, total, each, number. So if you need number, then you should divide total by each. So total time we have, time of each period we have, number of revolution will be 14.42, and here should be 14.40. Let's keep three significance figures, 14.4. Next question. Table 2 gives some statement about satellite orbits. Tick 3 boxes to show which 3 statements are correct. Use table from table 1 to help you answer. I will not use table 1. I know that the closer the satellites are, the faster they move. This is why I choose. So the higher the speed, the lower the height. So this is why I choose this. Lower height, shorter periods. This Kepler's law. So periods are proportional to the orbits, orbital radiuses, right? And the higher the number of revolution, shorter period. Number of revolution per day. If number of revolution is more, period is less. Yeah, this is sure. Okay. Finished with this paper, I think, right? Okay. Next question. Experiment. Question 10. 2 students use apparatus to investigate how intensity of ultraviolet light varies with distance. So we have torch, detector, ultraviolet meter, ruler, and we measure distance. Very good. The student takes readings for various distances. The ultraviolet meter only gives reading in whole numbers. The table shows the result. Right. Okay. Each student displays the result as a different graph. So we have graph 1 and graph 2. Graph 1 is continuous graph, best fit line, and graph 2 is bar chart. Discuss which is best for displaying this type of data. So graph 1 is for continuous data, can reveal anomalous reading, better for predicting any value. Graph 2 is good for discrete value. Actually here we have discrete value, no much difference between these two graphs. Suggest how students could improve the accuracy of the distance measurement. So read ruler at eye level. It means that eyesight at 90 degrees to avoid parallax. Rule parallel to torch and close to torch. Suggest why the reading on the ultraviolet meter remains the same for the last 3 readings. Background, ultraviolet radiation. Let's look. So here 3 values are almost the same. It means that in the room we have some background ultraviolet radiation. Sunscreen cream can be used to protect skin from ultraviolet light. The students changed the investigation to measure how effective the different sunscreen creams are at absorbing ultraviolet light. They place a thin sheet of plastic between the ultraviolet torch and the meter. They coat this plastic sheet with different sunscreen creams. Describe how the student should control the variables in the investigation. So same thickness of plastic, same thickness of cream, Same distance between torch and sheet, constant background light. More than enough because they need only, actually 4. Yeah, they need 4 ideas, we give 4 ideas. This question is about different waves. The diagram shows 2 types of brain wave, alpha and beta. Brain waves are caused by electrical signal in the brain. Which of the table correctly compares alpha and delta waves? So amplitude and frequency. So this is time scale. So time scale. If you have more oscillations per second, then it will be more frequent. So more frequent is here. More frequency. But amplitude is distance from, so amplitude, distance from rest position. So amplitude is greater here. So amplitude of alpha wave is smaller, yes, and frequency is higher. Answered. This was question 11. Now B. Waves produced in earthquakes can be classified as transverse or longitudinal. Or an earthquake wave is traveling in the direction shown to the arrow. Which row of the table correctly shows the motion of the particle in each type of wave? Transverse means at 90 degrees. Longitudinal means along, forward and backward. So we choose choice B. We finished with this question. Right, now the diagram shows a waterproof torch submerged in a tank of water. Some rays of light A, B, C, D are shown. Describe what is happening to the rays. First of all, rays A, B, C undergo refraction. So we see refracted ray. A is not deviated, C is deviated more than B, and for D we have no refracted ray. It means that we have total internal reflection. All light is reflected. This happens because angle of incident is greater than angle of critical angle, of material. In this case we have most carbon exists in the form of carbon-12, which is a stable isotope of carbon. Carbon-14 is another type of carbon. Carbon-14 forms in the upper atmosphere when a nitrogen nucleus absorbs a neutron. Complete the nuclear equation for the formation of carbon-14. So, neutron, it is nucleon, number 1 here, and has no charge, 0 here. Now balancing, 15 top value should be 15, so this is 1. 7 bottom value should be 7 here, so 1, 1, 1. So 1 nucleon and positive charge. It is proton. Compare an atom of carbon-14 and an atom of carbon-12. Both have 6 protons according to this information. 6 protons. You see, 6 protons. The rest are neutrons. So 14 means mass number. So 8 are nucleon number, 14 nucleons. So the rest are neutrons. So 8 neutrons and 6 neutrons. Carbon-14 is radioactive and decay by emitting beta minus particle. Describe what happens to the atomic number and mass number of carbon-14 when it decays. 1 neutron turns into a proton. Atomic number increases by 1. Mass number doesn't change because proton, nucleon number, mass number the same. proton changes into neutron changes into proton. The graph shows how the activity of the sample carbon-14 changes with. Use the graph to determine the half-life of carbon-14. So I took the maximum value 250. I know that during half-life it should decrease by 2. Decrease by 2 becomes 125. So I go to the graph and this point. So each small division is 100. This is why we have here 5050. No, each is 1000, sorry, 1000, because from 5000 to 10,000 we have 10 small squares, so each is 1000, half is 500, so this is 5000 and 500. So this is the half-life. A scientist uses carbon-14 dating to find the age of a very old wooden bowl. Here he uses this method. Take samples of wood of the same mass from a bowl and from a tree. Determines the correct activity of each sample of wood. Corrected activity. Determines the corrected activity. Finds the age of the bowl. Determines the ratio of carbon-14 in the bowl to the carbon-14 in the tree. States why the scientist has to correct the activity. Exclude background radiation. State why the scientist takes samples of the same mass. Because activity depends on mass. If you want to compare activity, you should have the same mass. The scientist is asked to find the age of dinosaur bone that is about 68 million years old. Explain why he would not be able to use carbon-14 dating to find the age of one. Activity will be too low to measure, as half-life is much less than 68 million years. Question 13. A student does 3 separate experiments to investigate conduction of thermal energy. In her first experiment, the student inserts 4 rods made of different materials into copper disc. She puts 8 wax rings onto each rod. She then hits the copper disc with the Bunsen burner. The diagram shows the experiment after the copper. So what we see in this experiment? So we see that heat has traveled longer distance and more wax rings disappeared, melted for copper, but less for plastic. Explain what this experiment shows about conduction. Copper is best conductor, plastic rod is best insulator, heat traveled farther in copper rod and less ring is left. Wax rings, interesting. In her second experiment, the student places some ice in a test tube and then fills the test tube with water. She puts a metal disc on top of the ice so to stop the ice from floating. She heats the top of the tube until the water boils as shown in the diagram. The water boils, water boils, but because water is poor conductor, heat doesn't reach ice, ice doesn't melt. Explain why the ice remains frozen when the top of the tube is heated. Water is poor conductor of heat, one idea. Heat doesn't reach ice, another idea. In her third experiment, the student inserts a wooden rod into the end of a brass tube. She then wraps a paper collar around the joint and heats the apparatus as shown in the diagram. So heating and burn part is wooden part. Why? Because here brass take heat away quickly and doesn't remain, but here rod doesn't take heat, it remains and burns the. So brass explain why the paper burns on the wooden rod but not on the brass tube. Brass tube is better conductor and takes heat from heated paper. This is why it is not burned. Okay, 14. A student uses apparatus to investigate the relationship between the speed of fluid and its pressure. The apparatus consists of pipe of variable diameter with 3 tubes attached. What we see, the water flows, and here level of water lowers. The student passes a constant flow of water through the pipe. State the equation linking pressure, difference, height, density, and G. So pressure equals density, G, height. So it means that here pressure is the lowest. The pressure at point Y is lower than pressure at point Y. Explain how the diagram shows the pressure is low. At Y less height, hence less pressure. A constant volume of water flows through the pipe each second. Explain how the speed of water at Y differs. Every second, the same volume of cylinder, which is area times speed, goes through the different paths. Less area should be more speed. The student hangs 2 balloons from the ceiling. He then uses drinking straw to blow air between balloons. So air goes through at higher speed, pressure decrease, and pressure outside is greater than pressure inside, so they push to explain why the balloons move towards each other when the student blows air between them. Refer to air speed and pressure in your answer. Greater speed of air between balloons, less pressure. Balloons are pushed towards each other by difference of pressure. So, our paper is over. In the syllabus you can find formulas that you should learn. So appendix 7. So here I show you this appendix. What else you have in this? So this is empty paper. 2 pages of formulas. This, by the way, this formula we used. So this formula we should memorize. This formula we used. And also, you should learn these symbols. So in this paper, they asked about the symbol, lamp, and others. Thank you for your attention. See you next time.